about semantic research data management in glaciology, with a special focus this time on the latest news. So we are going from Summit only to a real workflow integration. And this talk is by me and my colleague Florian Spreckelsen, who's also present in the session, and Johannes Freitag at the Alfred Wegener Institute in Bremerhaven. We already gave a talk about the software ChaosDB, which is at the center of this talk, in 2019. Slides and recording are available, and the links to those are also in the pad already. I will first give a short review of ChaosDB, the software, and then how we use it at the Alfred Wegener Institute. ChaosDB is a toolkit for agile and semantic data management. It has mainly, or it's one of its focuses is it has typed references between entities, which makes it ideal for modeling semantic context and also to making steps towards reproducible science. So we are trying to approach this directed graph of different results with the software. ChaosDB stores raw data only as reference to file or file-like objects, which makes it ideal for huge data files because ChaosDB itself is not concerned with the storage size. There's a powerful query language which allows the users to do most of the analysis right in the database already. And above all, it has a very flexible data model, which means that even if you modify your data structures and so to say your database scheme in scheme database systems, you don't need any kind of migration. We see ChaosDB in the sweet spot between SQL, between graph databases, and between data lakes, and we try to overcome the problems which these approaches present. ChaosDB was started at the Mathematical Institute for Dynamics and Self-Organization in Göttingen around 2011. It's been running stable for some 5 or 6 years now. It was released as HGPL in 2018 at GitLab. You can download it there, and has found increased adoption in multiple institutes in the last few years. And there's now commercial support available by Indiscale GmbH, where my co-author Florian and I work. And Indiscale has an own distribution of ChaosDB, which is branded as Linked, so you may see both names from time to time. But again, it's really just a wrapper around ChaosDB. It's all still HGPL, of course. Part 2 of the revision of what was also presented in the last talk 3 years ago. We use ChaosDB among other departments at the glaciology department at the Alfred Wegener Institute. There, ChaosDB is used for managing the ice cores, which you see in this image here. The ice cores were obtained at some expedition, stored at a very cold storage site, and ChaosDB manages when researchers request ice samples to do analysis on them, and its analysis then can also be linked within ChaosDB to this ice core, so that you have a full provenance graph. So you see that this analysis that comes from this procedure comes from this ice core, which was obtained at this expedition at this location. Today, I want to focus on what's new since the last time. There are several new developments in ChaosDB. It has a full version history. It has an automatic crawler to simplify data integration. It knows what georeferencing, and there's a completely new second API now, and which comes with new client libraries. And it also has features server-side enforced state machine now, which allows you to model workflows. Let's start with the first one. One question, of course, is how do I correct mistakes? because I might find out that in this case, for example, I've written 109, whereas I meant 209. So how do I do this and still comply with good scientific practice rules? And additionally, I may also simply want to know what earlier states of some entries in this database were. And to enable this, ChaosDB now keeps track of the full version history. So it knows who changed entities, when were those changed, and what was changed. One example could be who borrowed a sample at which time, how much of the sample was used up, which analysis was done at which step, and especially in which state was the sample when this and that analysis was done. I think it's best if I also switch to a live demo now. This demo is at the Digna Institute at the instance there, and here we have one iScore record. This iScore has some properties which you can see here. The iScore was cut into small pieces which are then stored inside bags, which are only references to other records, of course. And you can also see a short preview of the data here, which is generated live in the browser from the data. So, for example, we see that there was a entity measurement which took part from 0 meters to 30-something meters. But what I want to focus on today are now these measurements. So these here are all references to measurements, for example, some logging or cutting protocol which was done, or so some volume measurements. And now for this entity, if I click on this versioning icon, or this clock icon, I see, okay, there are previous versions, there's a previous version. I can also see the full history, and I can say, okay, let's just look at what this looked like in the 2nd of September 2020. I will open this in a new tab. I switch to the new tab now. And we see this is a different entry, obviously. It didn't have the analysis links which are present here. And if I see, okay, there's a warning, a newer version exists, I'm not at the current version now, I can go to the newer version, or I can look at the version info again with a big red warning, and I can load the full version history and then see again that Johannes Freitag here, our co-author of this talk, did these changes on this and this date. Okay, let's switch back to the talk. The next question we encountered, the next problem is, how do I get the data into my system? Well, you are a technical audience, you know, we don't want to do by typing this in manually. We want to automate stuff. And do not only want to automate it because this reduces the possibility of human mistakes. Automation is also important if we want to get our research software accepted by users, because normal lab users don't want to hear about yet another form they have to fill in after each step. They don't want to hear about new software with shiny buttons which they have to press now, which they didn't have to press before. And users want to keep their workflows, want to do what they've always done. So automation is really the key to acceptance. And of course, for all people who work with data, automation is fun because it means that we can start working with the data right away without needing to insert it manually. ChaosDB has a small script framework which we call the crawler. The crawler is something which you can run as a background job, and you can write plugins for this. And then the crawler typically first looks for data sources for potential data it might want to insert. Then these plugins are responsible for building entities out of the data which may need to be inserted. Then from these entities, a so-called identifiable is created, which is more or less a search or value pattern. And this identifiable is then used by the crawler to query the ChaosDB and find out if there are any entities in there already which match this pattern. If they are matching entities, those entities are updated. This is again the responsibility of the plugin. Or if there are no entities found, this entity can just be inserted as is. Because this merging of old and new data may lead to conflicts, and there's always the possibility that the plugin tells the crawler to not insert this automatically, but to notify administrators and look over the data and say if it should be imported or not, or if there should be any changes made to it. Next problem which we faced at the Alfred Wegener Institute was that a lot of real data which we find in real life has geographical data attached to it. This is not only geosciences, biology, humanities, geology and biology and humanities all may have this problem. And for the users at the Alfred Wegener Institute, displaying and filtering for geographical data was a top priority. So ChaosDB's web interface can now display data with latitude and longitude on a map. It can filter it for this. It can even display the geographical data. It can display the location for entities which do not have geographical data themselves, but which link to data with latitude and longitude. If you want, we can have a live look at this later if we have some time at the end. Next one. ChaosDB from the very beginning has had a REST API which works with XML over HTTP, and we still use this. But we also have a gRPC interface now, which overcomes the limitations of REST. So we are now able to have larger transactions in an atomic way. So we can, for example, insert and delete in one step and have it either succeed both or fail both. And based upon this gRPC interface, we wrote a few new clients. In C++, and as a kind of second layer client, which uses the C++ client, a client for Julia and for Octave. Clients for JavaScript and R are under active development at the moment. Yes, I think we have time for another short demo, because I think we have done a lot of presentations already where we show the Python client, which uses the old REST API. Let's now look at Octave. Octave is a free open source re-implementation of the MATLAB language, so to say. I run Octave in a Jupyter notebook here for this presentation. First, we want to connect to the ChaosDB package. Want to connect to the server and get some information about. Oh, I don't know if I actually started the server. Let's see if this works. It doesn't work. We have to do it again. Oh, it works. Okay, so it worked. We are connected to the server. We get some basic information, which at the moment is only the version of the server. So we're at 0.7.1. It becomes more interesting if we try to execute queries via Octave on the server, just in the same way as we would do it in the web interface to ChaosDB, which we saw before. So here, for example, we can enter queries here and say we want to find something. Of course, we can also do this in the programming languages. This demo server has some musical instruments and analysis on these musical instruments. So we are interested to find out where we want to find all those musical instruments, which are more expensive than 2,022 euros. And of these, we want to print out the result number 3, which will be one of these instruments. Let's see. Okay, instrument number 1 was successfully returned. We see this is John Lennon's guitar. This is a record as we requested. has some description, has some more metadata, which is not interesting for us at the moment, except maybe that the parents of this record is a reference to another entity, which is guitar. So we know that this really is a guitar, and it has a field of properties. Properties, which is a struct array in this case, cannot be displayed as one thing by Octave. So we want to look into this further. And at the moment now we are completely inside Octave, and we only use Octave tools. So we want to get the price. So we take this instrument, say get properties as struct, and from the struct, which is a plain Octave data, plain Octave data type, we then get the price attribute. And the price again is a more complex object. Get a value, of course, which is a little over 2 million, and it has a unit because in ChaosDB all numeric properties can have units, and you can also translate between units. So, for example, if you are searching for kilometers, you would also get units which have millimeters. Okay, so far for this one. And now for the last part of the new features that I want to present. The question, one question which also comes up pretty often, and which again somehow links to the first talk of this session. The question is how can we implement workflows? Workflows can be all kinds of things. Can be that in the life cycle of a sample which we want to manage in this data management, there are different responsibilities. For example, a different person may be responsible during sample acquisition, then during sample preparation, then after it's prepared, the data may need to be curated by a data curator, and only then other people may be allowed to use it for the analysis. Workflows can also represent standard operating procedures, so a preparation step. So you may want to know, I have a sample, for example, in chemistry or biology, which first needs to be treated this way, then needs to be stored for 3 hours at 40 degrees there, and then you can do the next step. All these things can be represented by state machines. And ChaosDB has special records which represent states and then allow certain transitions between these states. For example, you have in this example of a publication may start in the unpublished state, may undergo review, and only if this review is successful, it may go to published. We can find this also in the live server. If you want to try out ChaosDB for yourselves, there's a live demo server which is freely accessible for everyone. The data is reset nightly, so don't store anything important there. That's at demo.indiscale.com. So let's go there, demo.indiscale.com. Okay, welcome to Linked, which is just another name for ChaosDB. And we want to, here we are talking again about talking about musical instruments. So we say find records, musical analysis, yes. And what we get are 3 records. So these are 3 published musical analysis records. They're all published here, as you see here. Now, if I log in, it's simply a user admin password ChaosDB, which is also not safe, but it's publicly known. If I log in, I find that suddenly there are not only these 3 records which were there before, but now as an admin user, I have different access rights, and I can also see these 2 analysis records. One is unpublished, one is under review. Now, if I go here, if I click here, I can say, okay, I either want to reject this. So remember here, when it's under review, I can either publish it or reject it. Or I can publish it, which I do now, which means it will switch to being publicly visible. Let's remember what this is. Musical instrument is nice guitar, and the nice guitar should be visible now. I log out. I log out. I do this query again. And I see there are 4 results, and one of them is this nice guitar. Of course, if I log in again, I can also go the other way, take this nice guitar. I want to put it back to under review, which I cannot directly, because even if I'm the admin user, I cannot do anything which the server doesn't allow me to do. For the server forces me to first unpublish it, and then I can start a review and make it under review again. So I think that's it. Yes, here are some useful links, which are also all in the text, so you don't need to write them down now. Yes, I would like to thank you for listening, and yes, are there any questions?